Hey guys, today we're going to break down Chapter 3, Physiology and Histology of the Skin. There are 9 objectives from this chapter. Describe why learning the physiology and histology of the skin makes you a better esthetician. Describe the attributes of healthy skin. Distinguish the 6 primary functions of the skin. Explain the function of each layer of the skin from the deepest to the surface. Identify a hair follicle as an appendage of the skin. Identify the nails as an appendage of the skin. Describe the functions of the 2 types of nerves. Explain what is produced by the 2 types of glands of the skin. And lastly, distinguish the factors influencing skin health. Skin histology and physiology involves the study of the anatomy, layers, and functions of the skin. Physiology is the study of the functions and activities performed by the body structures, including physical and chemical processes. Histology is also known as microscopic anatomy, the study of the structure and composition of tissue. So, skin physiology and histology involves the study of the structure and composition of skin tissue. Estheticians who specialize in the health and beauty of skin are sometimes referred to as technicians, therapists, or specialists. Committed to becoming a skin expert means you develop an understanding of your client's unique skin characteristics and responses. You can make personalized treatment recommendations and prescribe a home care regimen that will help keep the skin healthy and vibrant. An esthetician's primary focus is on preserving, protecting, and nourishing the skin. Estheticians should have a thorough understanding of physiology and histology because the layers, components, and functions all work with other body systems to protect and regulate the skin and other parts of the body. The aging process, as well as the effects of ultraviolet damage, hormonal influences, and nutrition on the skin health, all factor into the skin's health and appearance. And lastly, as an esthetician, you want to know how to best maintain the skin at its optimum health, and with a deeper understanding, you as a therapist can confidently treat the skin, which is a sophisticated system. Here are a few fun facts about skin. So, the epidermis is much thinner than the dermis. Anytime that we have a scar on our body, scars lack hair and sweat glands, so that means that if you have a scar, there will be no sweat produced there. Also, there will be no hair. There's also a unique fact of everyone has the same number of melanocytes or melanocytes. What is the determining factor in how much melanin is produced is how active those melanocytes are. The average person has about 22 square feet of skin, and then the thinnest skin is found on our eyelids, and the thickest skin is found on our soles of our feet. The skin also is composed of 3 layers, which we're going to break down later in the slideshow. We have the epidermis, the dermis, and the subcutaneous layer. Skin, or the integumentary system, is the largest organ in the body. It is a strong barrier designed to protect us from the outside elements. Hormones, growth factors, and other biochemicals control the skin's intricate functions. The basic material and building blocks for our body's tissues are proteins. Amino acids are the building blocks of proteins. Amino acids form peptides, and peptides form proteins. Proteins have many roles in maintaining skin health. Appendages of the skin, which means extensions of the skin, include hair, nails, sweat glands, and oil glands. Healthy skin is slightly moist, soft, smooth, and somewhat acidic, which means that the pH of the skin is around 5 on the pH scale. So that means that the skin is somewhat or slightly acidic. The skin is similar to a multifunction tool. It acts as a shield for the body. It is waterproof and it's an insulator that protects the body against extreme heat, cold, and damaging UV rays. Skin is a barrier to protect against harmful chemicals and bacteria, preventing infection. Skin plays an important role in bone health and producing vitamin D. Skin does all of this while being flexible enough for the body to engage in motion while maintaining a healthy exterior to allow us to look good and feel comfortable. For these reasons, there are 6 primary functions of the skin. Those 6 functions include sensation, protection, heat regulation, excretion, secretion, and absorption. Let's break them all down. Touch is one of the first senses to develop. Nerve fibers in the skin sense when we are touched. Depending on the type of stimulation, sensations felt on our skin causes us to feel, react, or move. Different nerve sensors help us to detect different sensations and perceive changes in our environment such as heat, cold, touch, pain, and pressure. Nerve sensors send messages to the brain, and motor nerves send messages back to relay to the body how to respond. The sensation of heat will cause us to pull away from a hot stove burner. A massage sends messages to the brain through nerve stimulation and lower stress in the body as well as promote circulation. Sensory nerve fibers are most abundant in the fingertips and are designed to be one of the most sensitive parts of the body. As you can see here, we have various types of nerve endings that correlate to the different senses that we have. So, Merkel's disc is why we're able to feel and understand when we're touched. The Meissner's corpuscle, that one lets us know when we're being touched in a sensitive way. The Pacinian corpuscle lets us know when there is pressure on our body or around our body. We have hair follicle receptors, which also lets us know that we are being touched. Krause's corpuscle, which lets us know when something is cold. And then we have free nerve endings that lets us know when there's either pain or a temperature change. And Ruffini's corpuscle, which also lets us know when there is touch or pressure being applied to the skin or to the body. Protection. The skin is a thin yet very strong protective barrier to outside elements and microorganisms. It has many defense mechanisms to protect the body from injury and invasion. Sebum, which is oil on the epidermis, gives protection from external factors such as invasion of certain bacteria. The acid mantle is the protective barrier made up of sebum, lipid, sweat, and water. These components form a hydrophilic film to protect the skin from drying out and from exposure to external factors that could damage it. Hydro means water, lipidic means oil. A hydrolipidic film provides an oil-water balance on the skin surface. The acid mantle has an average pH of 5.5. The balanced pH of the skin is important to protect the body from pathogens and to regulate enzymatic functions. The acid mantle is part of the skin's natural barrier function. The barrier function is the skin's mechanism that protects us from irritation and intercellular transepidermal water loss, or what we call TOOL. The water loss caused by evaporation on the skin's surface. Lipids are substances that contribute to the barrier function of the epidermis. Lipids are protective oils and are part of the intercellular matrix between the cells. Damage to the barrier layer is the cause of many skin problems including sensitivities, aging, and dehydration. As you can see here in the graphic, normal skin has a normal functioning barrier. The barrier is intact, which means that it is able to repel any kind of pathogens, allergens, viruses, etc. Cells in the stratum corneum are oval shaped and they are all about the same size. And then you can also see that moisture is being trapped in the deeper layers of the epidermis. To the right, damaged skin looks completely opposite. The barrier is broken, hence allowing the skin to be susceptible to be penetrated by allergens, viruses, pathogens, and other harmful microorganisms. The stratum corneum cells are not even and they're not all the same shape. There's also a lack of moisture or loss of moisture because that moisture is not able to be locked into the deeper layers of the skin. So that is a difference in normal skin and damaged skin and what happens. Heat regulation is our next function of the skin. So I think that we all know that the average thermostat for the body is 98.6 degrees. When the outside temperature changes, the skin automatically adjusts to warm or cool the body as necessary. The body maintains thermal regulation through evaporation, perspiration, radiation, and insulation. Millions of sweat glands release heat from the body through perspiration to keep us from overheating. We then cool ourselves through evaporation on the skin's surface. Blood flow and blood vessel dilation also assist in cooling the body. We protect ourselves from the cold by constriction of the blood vessels and decreased blood flow. Additionally, the body's fat layers help to insulate and warm the body. Hair follicles also help to regulate body temperature and protect from heat loss. When we are cold, the erector pili muscle attached to the hair follicles contract and cause goosebumps. This reaction is thought to warm the skin by the air pockets that are created under the hairs that stand up when the muscle contracts. Excretion and secretion are also functions of the body or functions of the skin. As functions of the skin, excretion helps us to excrete perspiration, and this is done through the sudoriferous glands. The sudoriferous gland serves to prevent the body from overheating. The liver and kidneys do the detox work. Heavy sweating can cause loss of fluids, dehydration, and loss of mineral balance needed to keep the body functioning optimally. Sweat, just like sebum, is also a part of the acid mantle. Then we have secretions. So sebum, which is an oily substance that protects the surface of the skin and lubricates both the skin and the hair. Sebaceous glands, which are also known as our oil glands, are appendages that attach to the follicles that produce sebum. These oils help to keep the skin soft and protect from outside elements. The skin is approximately 50 to 70% water. Sebum coating the surface of the skin slows down the evaporation of water, also known as transepidermal water loss, or what we call TEWL, TEWL, and helps maintain appropriate water levels in the cells. Emotional stress and hormonal imbalance can stimulate oil glands to increase the flow of sebum, which can lead to skin problems such as acneic breakouts. We're now on objective 4, explain the function of each layer of the skin from the deepest to the surface. The skin is comprised of 3 main components. We have the hypodermis, or what we call the subcutaneous layer. We have the dermis and the epidermis, and we're going to start at the deepest layer and work our way outward toward the surface. So let's start with the subcutaneous layer. The subcutaneous layer, also known as the hypodermis or the superficial fascia, is composed of loose connective tissue or what we call subcutaneous tissue. We also call this layer or this tissue adipose tissue. This layer is 80% fat. This tissue creates a protective cushion that gives contour and smoothness to the body, and it is also a source of energy for the body. This layer tends to decrease and thin as we age. So again, I'm not sure if you guys can see my mouse, but I am circling the hypodermis or the subcutaneous layer of the skin. Again, it is the deepest layer of the skin. It is also called the adipose layer, the subcutaneous layer, and it's responsible for our body's contour and an energy source as well. The next layer is the dermis. The dermis is, if you're looking at the graphic, it's all of the middle portion of this graphic that has the pink background. And as you can see to the right, the brackets tell you what is the dermis, what is the hypodermis, and what is the epidermis. So the dermis. The dermis is also referred to as the derma, or we may also call this the corium or the cutis. Some people refer to this layer as the true skin. It is the support layer of connective tissues above the hypodermis. The dermis is about 25 times thicker than the epidermis, and again, it consists of two layers, the reticular layer below and the papillary layer above. The dermis primarily comprises of connective tissues made of collagen, protein, and elastin fibers. The reticular layer, the denser, deeper layer of the dermis, is comprised mainly of collagen and elastin. Damage to these elastin fibers as they break down is the primary cause of sagging, wrinkles, and intrinsic aging, loss of elasticity in the skin. Stretch marks are caused by damaged elastin fibers. Collagen and elastin are broken down by UV or ultraviolet damage, smoking, and environmental influences such as air pollution. The papillary layer connects the dermis to the epidermis. The dermal papillae are membranes of ridges and grooves that attach to the epidermis. Attached to the dermal papillae are either looped capillaries that nourish the epidermis or tactile corpuscles, which are the nerve endings that are sensitive to touch and pressure. Please note that the papillae in the hair follicle are called hair papillae and are small cone-shaped structures at the bottom of hair follicles. The blood supplies nourishment within the skin through capillaries. The papillary layer comprises 10 to 20% of the dermis. Collagen and elastin are loose and are more widely spaced here than in the reticular layer. And when it comes to collagen, collagen is a protein substance of complex fibers that give skin its strength and it's necessary for wound healing. Produced by fibroblasts, collagen makes up 70% of the dermis. Fibroblast cells produce proteins and aid in production of collagen and elastin. Elastin is a fibrous protein that forms elastic tissue and gives skin its elasticity. I'm not sure if you've ever heard of GAGs, or what we call glycosaminoglycans, which are large protein molecules and water-binding substances found between the fibers in the dermis. GAGs are polysaccharides, that is, protein and sugar complexes. Glycosaminoglycans work to maintain and support collagen and elastin in cellular spaces, keeping protein fibers in balance. They also help collagen and elastin maintain moisture. They interact with copper peptides in our system for cellular repair. A healthy fluid intake is essential to keep the GAGs functioning properly. Beneficial hydrating fluids such as hyaluronic acid are part of this dermal substance. So, hyaluronic acid is a glycosaminoglycan, or what we call a GAG, a GAG. Lymph vessels remove waste products, bacteria, and excess fluid. Fibroblasts, lymphocytes, Langerhans cells, mast cells, and leukocytes are also found in the dermis. Other components give tautness or firmness to the skin by interacting with elastin and hyaluronic acid. Hormones such as epidermal growth factors, or what we call EGFs, and fibroblast growth factors, which we refer to as FGF, stimulate fibroblasts cells, proteins, and DNA synthesis. In the dermis is a fluid called extracellular matrix, or ECM, composed of collagen and protein, and GAGs, which stand for glycosaminoglycans. These intercellular substances comprise fluid with other components to maintain balance, provide dermal support, and assist cell metabolism, growth, and migration. As you can see here, when we take a look at younger skin and older skin side by side, if you're looking at the dermis area, you can see that younger skin has stronger collagen connections, stronger elastin connections, and over to the right on the older skin, those connections are broken or they're either weakened. Okay, so that is a clear example of the aging process and how collagen and elastin reduces over time. You can also tell the difference on the surface of the skin between younger and older skin. In younger skin, the skin is going to be more taut and flat on the surface, and older skin will start to be or will begin to develop fine lines and wrinkles. So simply put, in older skin, elastin fibers are broken, and then we have atrophy of our collagen, meaning we have a breakdown of our collagen. The dermal epidermal junction, or what we call the DEJ, connects the dermis to the epidermis. This junction consists of a connective collagen tissue with many small pockets and holes. Collagen fibrils from the dermis are embedded into these layers and provide strength and adhesion. Keratin filaments on the epidermis side also ensure strength and adhesion to the junction. Some states define the esthetician's scope of practice as not beyond the DEJ or not beyond the dermal epidermal junction, meaning estheticians cannot treat skin beyond the epidermis. So now let's get into the top layer or the outermost layer, which is what we refer to as the epidermis. So the epidermis is the outermost layer of skin, and this is the epithelial tissue that covers the body. It is a thin protective covering with many nerve endings. The epidermis is composed of 5 layers called strata, or in the singular form, we call them stratum. The deepest layer of the epidermis is referred to as the stratum germinativum. That is the germination or the growth layer. It's also known as the basal cell layer. And it's located above the dermis and is composed of a single layer of basal cells laying on what we call a basement membrane. In this active layer, stem cells undergo continuous cell division, which we refer to as mitosis, to replenish the skin cells that are regularly shed from the surface. Stem cells are basically mother cells that divide to produce daughter cells in a remarkable process. Cells in the basal layer produce the necessary lipids that form cell membranes that hold cells together. Merkel cells, which are sensory cells, and touch receptors are also located in the basal layer. The stratum germinativum also contains melanocytes, or melanocytes, which are cells that produce pigment granules in the basal layer. About 5 to 10% of basal cells are melanocytes. The pigment-carrying granules, called melanosomes, then produce a complex protein called melanin, which determines our hair, skin, and eye color. So again, as just a friendly reminder, the stratum germinativum is the deepest layer of the epidermis. It is referred to as the live or the active layer. This is where all of the cell division, all of the mitosis takes place. This is where the mother cells create daughter cells to help replenish the cells that are shed on the upper layers of the epidermis. Also, as another friendly reminder, in the stratum germinativum, this is where melanin is produced. We're going to break this down a little bit later in the next few slides, so I'm going to circle back to melanin production. We're going to circle back to tyrosinase as well. I'm going to keep moving through the slideshow. The second layer of the epidermis is the stratum spinosum. And again, we are looking at these layers from deepest to the most surface layer. So right above the stratum germinativum, we have the stratum spinosum. This layer is also called the spotty layer. And what happens here is cells continue to divide and change shape, and enzymes are creating lipids and proteins. Cell appendages which resemble prickly spines become desmosomes, the intercellular structures that assist in strengthening and holding cells together. Desmosomes are simply keratin filaments, or we can also call them protein bonds that create junctions between the cells. These strengthen the epidermis and assist in intercellular communication. Also found in the stratum spinosum are Langerhans immune cells, which protect the body from infections by identifying foreign material. The immune cells help to destroy foreign invaders. Keratinocytes and melanocytes work in synergy here, forming the even placement of pigment granules. Lamellar granules are cells that contain lipids to maintain barrier function. The spinosum is the largest layer of the epidermis. The third, or what I like to call the middle layer of the epidermis, is the stratum granulosum. The stratum granulosum, also known as the granular layer, is composed of cells that resemble granules and are filled with keratin. The production of keratin and intercellular lipids all take place here. In this layer, enzymes dissolve the structures, which are desmosomes, that hold the cells together. So remember, desmosomes hold cells together, but as our cells are moving upwards towards the outermost layer of the epidermis, enzymes dissolve these desmosomes. As these cells become keratinized, they move to the surface and replace the cells that shed from the stratum corneum. Natural moisturizing substances such as triglycerides, ceramides, waxes, fatty acids, and other intercellular lipids are made here and are excreted from cells to form components of the skin's waterproof barrier of the top layer. These water-soluble compounds are referred to as natural moisturizing factors and hydrate the lipid layers surrounding cells, absorb water, and also prevent water loss. The stratum lucidum, this is simply the transparent layer or the thin clear layer that allows light to pass through. It's a clear layer of dead skin cells just under the stratum corneum. And this layer is the thickest on the palms of the hands and soles of the feet. That's as much as I feel like I really need to say about this layer. But I would like to add that this stratum lucidum layer is the layer that allows us to absorb light. So not only does this allow us to absorb light from the sun, but also in our treatment room, it allows our clients to absorb light from our LED treatments, IPL treatments, laser treatments, etc. The final and last outermost layer of the epidermis is the stratum corneum. So, the corneum has a few nicknames. Sometimes it's referred to as the horny layer or the cornified layer, okay? It's the outermost layer of the epidermis. Estheticians work extensively with this layer. The stratum corneum is very thin, yet it is waterproof and permeable. It regenerates itself, detoxifies the body, and it also responds to stimuli. Keratinocytes on the surface have hardened into corneocytes, which are the waterproof protective cells. These dead protein cells have dried out and they lack nuclei. This layer is referred to as the horny layer because these cells look like scales, or they are scale-like. Keratinocytes are continuously shed from the skin in a process called desquamation. These cells are replaced by new cells coming to the surface from the lower stratums. The process of desquamation and replacement is known as cell turnover, which is a big thing. in skincare. We're always concerned about cell turnover. So, just as an FYI, the average adult cell turnover rate is about every 28 days, depending on the person's age, lifestyle, and health. The cell turnover rate slows as we age. Average cell turnover for babies is about 14 days. In your teens, it takes about 3 to 4 weeks. And by the time you are 50 or over, your cell turnover may take anywhere from 42 to 82 days. Understanding the process of cell turnover will help you make better decisions about how to treat aging skin. Cells and oil combine to form a protective barrier layer on the stratum corneum. Lipids of the cell membrane, such as phospholipids and essential fatty acids, determine the health of this protective barrier. So, in general, the stratum corneum has 15 to 20 layers of cells. The stratum corneum has a thickness between 0.01 and 0.04 millimeters. The keratinocytes on the surface of the skin are also called squamous keratinized cells. The word squamous just means flat or scaly. There are different terms used to describe the same cell, so it's helpful to remember these surface cells are both flat and they're also hardened. So, hardened can be also referred to as cornified. So that's where we get the terms cornified and squamous cells in this layer. So I said we would circle back to skin color, melanin, melanocytes, and melanosomes. And so again, as you can see here, these are the 5 layers. This slideshow is showing us the 5 layers of the epidermis, this graphic here. And as you can see at the very bottom layer, that is the basal cell layer. Ladies and gentlemen, this is the layer where our melanin is produced, okay? So melanin is a pigment that protects us from the sun. Every person has the same number of melanocytes, or melanocytes, however you want to say that, or pigment-producing cells. Both internal and external factors affect melanin activation and production. Differences in genetic skin color are due to the amount of melanin activated in the skin and the way that it is distributed. Individuals with darker skin and melanin have more activity in their melanocytes. This is an example of an internal factor. An external factor influencing melanin production would be sun exposure. Melanin production is stimulated by sun exposure and protects the cells below by absorbing and blocking UV radiation. Melanocyte cells make melanosome spheres, which are transferred to keratinocytes. Melanosomes carry the pigment granules that provide the skin's color. One melanocyte will deposit pigment-carrying melanosomes into about 30 keratinocytes through its dendrites. A dendrite is basically like a branch or a branch or something that flows in a certain way, kind of similar to a tree. So dendrites are the arms or cellular projections that branch out to interact with other cells in the extracellular matrix between the cells. Again, this process is how pigment darkening occurs. Tyrosinase is an enzyme that stimulates melanocytes and thus produce melanin. So we all produce tyrosinase. It is an enzyme that is produced within our bodies. When we get into the later chapters of our aesthetics book and we start to talk about products and ingredients, we're going to talk about tyrosinase inhibitors. So there are products and ingredients that we can put on the skin or apply to the skin to inhibit the production of tyrosinase. And again, tyrosinase is an enzyme that our body produces that helps us to hence produce melanin. And as you see, melanin will travel as a dendrite through the other layers or upper layers of the epidermis. I hope this is making sense. If you want to read more about this, you can find this on page 98 of our standard aesthetics Milady textbook. I also want to mention before I leave the topic of melanin, there are 2 types of melanin that our body produces. We have pheomelanin, which produces red to yellow pigments in color. And then we have eumelanin, which produces dark brown to black pigments in color. People with light colored skin mostly produce pheomelanin, while those with darker colored skin produce mostly eumelanin. Individuals with fair skin have approximately 20 melanosomes per keratinocyte, and people with darker skin have about 200 melanosomes per melanocytes. We're now getting into Objective 5 and 6. Objective 5 identifies the hair follicle as an appendage, and Objective 6 identifies the nails as an appendage. So the term appendage just simply means an extension of a larger part or a larger whole. In terms of our hair follicle as an appendage of the skin or an extension of the skin, our hair is a slender thread-like outgrowth of the scalp and skin. An esthetician needs to understand this appendage in order to perform treatments like body waxing, sugaring, and brow shaping. Due to hormonal influences, there are different male and female hair growth patterns, genetic influences that genetics influence the distribution of each person's hair, along with its thickness, quality, color, rate, and growth, and whether it's curly or straight. The speed of hair growth is roughly about a half an inch per month, which is about 6 inches per year. With age, the speed of hair growth might slow down to as little as 0.1 inch a month. And then there are also two types of keratin. Alpha keratin is softer, beta keratin is harder. You may want to know that for your test. And then hair contains about 90% of hard B keratin. It has lower moisture and fat content than soft A keratin, and it's particularly tough, elastic material. Keratin forms continuous sheets, such as fingernails, or either long endless fibers, such as hair. Hard keratin does not normally break off or flake away. It remains a continuous structure. Hair also contains melanin, which determines our hair color. Abnormalities such as extremely curly hair or rapidly growing bacteria and the inability of the follicle to take in oxygen along with excessive sebum production can contribute to ingrown hairs and folliculitis and inflammation of the follicle. We will discuss hair growth in a more extreme way in Chapter 11, Hair Removal. Objective 6, identify the nails as an appendage of the skin. So the nail as an appendage of the skin is a hard translucent plate that protects the fingers and toes. The nail is composed of hard keratin as well as hair. As you can see on the structure, there are different components of the nail structure, and the technical term for the nails is an onyx. The hard or horny nail plate contains no nerves or blood vessels. And then in terms of fingernail growth, the growth rate of our fingernails is faster than the growth rate of our toenails, and our nails grow faster in the summer than they do in the winter. And then in terms of how fast our nails grow per month, your nails will grow anywhere from 1/10 to 1/8 of an inch per month, which means it takes about 4 to 6 months for fingernails to fully grow out. An esthetician may work in the state where performing nail services is a part of the scope and practice. Additionally, some symptoms of disease and disorders that influence the skin are evident on the nails. A person with a circulatory disorder may have cyanotic nails, for example, and cyanosis is when a person has purple or bluish tone under their fingernails. So we do offer the dual manicures esthetician program in Texas, and if you are a dual manicures esthetician, then you will learn more in depth about nail care and nail structure. So that is as much as I wanted to dive into that at this time. All right, so objective number 7 starts on page 103. If you guys are following along in your textbook. So we're going to describe the functions of the two types of nerves within our skin. Okay, so nerves are like cord-like bundles of fibers made up of neurons through which sensory stimuli and motor impulses pass between the brain or other parts of the central nervous system and the eyes, glands, muscles, and other parts of the body. Nerves form a network of pathways for conducting information throughout the body. There are two types of nerves, which are motor nerves and sensory nerves. Motor, or what we call efferent nerves, convey impulses from the brain or spinal cord to the muscles or glands. These nerve fibers stimulate muscles such as the erector pili muscle attached to the hair follicle. Erector pili muscles cause goosebumps when you're cold or frightened. Secretory nerve fibers are motor nerves attached to sweat and oil glands. They regulate excretion from sweat glands and control sebum output to the surface of the skin. Then we have sensory nerve fibers, or we call these afferent nerve fibers. And these fibers send messages to the central nervous system and brain to react to heat, cold, pain, pressure, and touch. Objective number 8, explain what is produced by the two types of glands of the skin. The dermis of the skin contains two types of duct glands, each producing different substances. The sebaceous gland secretes oil, while the sudoriferous gland excretes sweat. Sebaceous glands are connected to hair follicles and produce oil, which protects the surface of the skin. If the duct becomes clogged, open or closed comedones are formed, which means blackheads or whiteheads are formed. Blackheads are open comedones, whiteheads are closed comedones. The oily secretions lubricate both the skin and hair. Sebaceous glands are larger on the face and scalp than on the rest of the body. Our sudoriferous glands help to regulate body temperature and eliminate minute amounts of waste products by excreting sweat. The excretion of sweat is controlled by the nervous system. Normally, 1 to 2 pints of fluids containing trace amounts of minerals such as sodium, potassium, and magnesium are eliminated daily through sweat pores in the skin. There are two types of sweat pores or sweat glands, which we have the apocrine glands and the eccrine glands. Let's break those two down. The apocrine glands are a coiled structure attached to the hair follicles and are found under the arms and in the genital areas. Their secretions are released through the oil glands. Apocrine function is sensitive to adrenaline, so sweating can occur during times of anxiety, stress, fear, sexual arousal, and pain. Odors associated with these glands are due to the interaction of the secretions and bacteria on the surface of the skin. Then we have eccrine glands. Our eccrine glands are found all over the body, but primarily on the forehead, palms of the hands, and soles of the feet. They have a duct and pore through which secretions are released onto the skin's surface. These glands are not connected to hair follicles in any way. Eccrine glands are more active when the body is subjected to physical activities or high temperatures. Eccrine sweat glands do not typically produce offensive odors, so that's something that you want to definitely notate about the difference in the sweat glands. If you want to read more on those, you can find that on page 104 in our Milady Standard Aesthetics textbook. We are now on Objective 9, distinguishing the factors that influence skin health. In order to survive, cells need these important elements: nourishment, protection, and the ability to function properly through respiration, circulation, elimination of waste, and continual replacement or proliferation. Skin health and aging of the skin are both influenced by many different factors, including heredity, sun exposure, the environment, healthy habits, nutrition, and general lifestyle. In terms of the immune system and the skin, our immune system is a complex defense mechanism that protects the body from foreign substances. The immune system is activated when antigens, which are foreign invaders, are identified. Antibodies are molecules formed to fight and neutralize bacteria, viruses, and antigens. Langerhans cells, T cells, and leukocyte cells are part of the immune system. Again, Langerhans cells are dendritic in form, just like our melanocytes. And again, dendritic means that they are branched in form, resembling a tree. So, our Langerhans cells work to absorb, process, and carry antigens to the nearest lymph nodes for further immune system action. Another part of the immune system involves leukocytes, the white blood cells that have enzymes to digest and kill bacteria and parasites. These white blood cells also respond to allergies. A T cell is a type of lymphocyte. T cells play an important role in the immune system by attacking virus-infected cells, foreign cells, and cancer cells. T cells get their name from the thymus gland where they mature. Skin nourishment. Blood and lymph are fluids that nourish the skin. Networks of arteries and lymphatics send essential materials for growth and repair throughout the body. Water, vitamins, minerals, and other nutrients are all important for skin health. Blood supplies nutrients and oxygen to the skin. Nutrients are molecules from food that we consume, such as protein, carbohydrates, and fats. Topical products with small molecules can nourish the epidermis. Networks of arteries and lymph vessels in the subcutaneous tissue send their smaller branches up to the dermal papillae, follicles, and skin glands. The health of the skin cells depend on our cellular membrane and the water-holding capacity of the stratum corneum, which this is where cell protection comes into play. Phospholipids, glycolipids, cholesterol, triglycerides, squalene, and waxes are all different types of lipids found in the stratum corneum and cell membranes. Intercellular lipids and proteins surround cells and provide protection, hydration, and nourishment to cells. Ceramides are a group of waxy lipid molecules such as glycolipids that are important to barrier function and water holding capacity. 50% of lipids in the stratum corneum are ceramides. Lipids are reduced in the skin if the skin is dry, damaged, or mature. Topical products containing peptides, hyaluronic acids, ceramides, and other lipid benefits the skin that is damaged from both intrinsic and extrinsic aging. These products expedite the regenerative processes of the body and promote healing. Exfoliation removes and depletes lipids, so topical product reapplication is necessary to balance what is lost when we exfoliate the skin. If you want to read more on cell protection, you can find this on page 106 in the Milady Standard Aesthetics textbook. Cell replacement is also another component or another function that happens within our skin. The body replaces billions of cells daily. The cells of organs such as the skin, heart, liver, and kidneys are replaced every 6 to 9 months. Cells of the bones are replaced every 7 years. Unfortunately, elastin and collagen are not easily replaced by the body, and the skin does not regain its once pliable shape after being stretched or damaged by UV radiation and environmental pollution. However, research shows that certain skincare treatments and ingredients such as vitamin A, alpha hydroxy acids, alpha lipoic acid, and other growth factors stimulate skin cell turnover and reduce visible signs of aging. Regular cell turnover is necessary for skin to be healthy. And I also want to highlight, I mentioned alpha lipoic acid. So, alpha lipoic acid has antioxidant effects on the skin, and alpha lipoic acids help to improve elasticity, texture, hydration, reduce fine lines and wrinkles, and alpha lipoic acid also helps to um, regenerate vitamin C and vitamin E. So that's your fun fact about alpha lipoic acid. You can read more on that on page 107. Sun damage is another factor that we have to consider when it comes to having healthy skin. The sun and ultraviolet radiation have the greatest impact on how our skin ages. According to the U.S. Department of Health and Human Services, ultraviolet radiation, or what we call UVR, is a proven carcinogen. UV meaning it's cancer causing. UV exposure alters DNA and can cause skin cancer. Approximately 80 to 85% of our aging is caused by sun exposure. So 80 to 85% of our aging is caused by sun exposure. As we age, the collagen and elastin fibers of our skin naturally weaken. This weakening is accelerated when the skin is frequently exposed to ultraviolet radiation. UV reaches the skin in three different forms. We have UVA, UVB, and UVC. UVA radiation, also known as aging rays, so the A stands for aging, contributes for up to 95% of the sun's UVR that reaches the Earth's surface. The longer wavelengths of UVA penetrates deeper into the skin and causes genetic damage and cell death. UVA weakens the skin's collagen and elastin fibers, causing wrinkling and sagging of the tissues. UVB radiation, also known as burning rays, so the B stands for burning, causes burning of the skin as well as tanning, aging, and cancer. UV penetration is shorter than and not as deep as UVA. However, these wavelengths are stronger and more damaging and can also damage the eyes as well. UVC radiation has more energy than UVA and UVB and reacts with the ozone high in our atmosphere and from human-made sources such as welding torches, UV sanitizing bulbs that kill bacteria and other germs. The effects of, go to my next slide, of HEV light, or what we call high energy visible light, is a new consideration when working on the skin, and questioning your client's exposure to this light is a valid inquiry during consultation. Blue light from your TV, computer, and smartphone, that is HEV light, is said to penetrate the skin more deeply than UV rays and damage collagen, hyaluronic acid, and elastin. Isn't that a fun fact? You can find this information on page 108 and 109 in your standard Aesthetics Milady textbook. All right, so let's talk about free radical damage. I'm not sure if you've ever heard of this, but all cells in our body like to be in a state of homeostasis. And what homeostasis just means is it's a stable internal environment despite any external changes or functions going on around it. Okay, so all of the cells in our body like to be in homeostasis, from individual body systems to microscopic cells. Molecules lose one electron due to damage from UV rays, the environment, poor nutrition, unhealthy lifestyle, or injuries. Inflammation creates free radicals. Free radicals speed up the aging process and creates an unhealthy state. Free radicals have an unbalanced electrical charge. They are unstable, and a chain reaction of cellular destruction begins as they steal electrons from other molecules to try to put themselves back together in a state of balance. How do we fight free radicals? With antioxidants. So, free radicals are superoxidizers that not only cause oxidation reactions but also produce new free radicals in the process. The prevention of free radical formation is a critical process and complex task that is necessary for cells to survive. Antioxidants are components that have an extra electron. So, antioxidants are vital to neutralize this chain reaction by donating their electrons to stabilize the free radicals' electrons. So, things like proteins, enzymes, vitamins, and metabolites are all antioxidants which help us to combat free radicals. If you want to read more on that, you can find that on page 110 in your Milady Standard Aesthetics textbook. In terms of skin health and the environment, while the sun may play a predominant role in how the skin ages, changes in our environment also greatly influence the aging process. So, climate, humidity levels, and other environmental factors also affect the skin. Routine cleansing at night helps to remove the buildup of pollutants that have settled on the skin surface throughout the day. Applying daily moisturizers, antioxidants, growth factor serums, peptides, sunscreen, and even foundation products help to protect the skin from airborne pollutants and environment. Skin health and lifestyle choices are also a factor that we need to consider when we're trying to make changes for our own skin or client skin. What we choose to put in our bodies significantly affects the overall health. The impact of poor choices can be seen most visibly on the skin. So, smoking, drinking, drugs, and having an unbalanced diet with heavily processed foods are all greatly influenced in the aging process. Okay, so you want to be aware of how these habits affect the skin so that during your consultations you can stress the benefits of good nutrition, exercise, having a balanced lifestyle, and stress reduction can help your clients. Also, smoking and tobacco use not only causes cancer, but are also linked to premature aging and wrinkling of the skin. Nicotine in tobacco causes contraction and weakening of the blood vessels and small capillaries that supply blood to tissues, causing a decreased circulation. Eventually, these tissues are deprived of essential oxygen, and the skin surface may appear yellowish or gray in color and can look dull. So, that's one of the ways that you can see how smoking can uh, affect your skin. Lack of oxygen and nutrients accelerates skin aging. Also, use of some prescription or illegal drugs also affects the skin. Certain drugs have been known and shown to interfere with the body's intake of oxygen, thus affecting healthy skin cell growth, or cell growth. Some drugs can even aggravate serious skin conditions such as acne. Okay, so let's talk about glycation. Um, Glycation is a destructive process, okay? And it's caused by an elevation in blood sugar. So, glycation is the bonding of a protein molecule to a glucose molecule, resulting in the formation of damaged, non functioning structures known as advanced glycation end products. Glycation alters protein structures and decreases biological activity. For example, glycation contributes to the aging of the skin, contributing to wrinkles and hyperpigmentation. When collagen is cross-linked by sugar, it leads to stiff, sagging skin. When blood sugar is elevated, we are in an inflammatory state. So, glycation is an unhealthy biological process for many reasons. A healthy lifestyle and a diet without excess sugar intake can help keep sugar levels balanced in the body, hence preventing glycation. As we age, our skin changes significantly, and this is partially because of shifts in our hormone balance. Estrogen, which is present in both men and women but is predominant in women, is a crucial hormone for good health and the appearance of the skin. Estrogen is anti-inflammatory, it is an antioxidant, and it's a key factor in key repair. Did you know that? That's a nice fun fact. The hormone is also responsible for maintaining health in several areas such as coordination, balance, skin moisture, vision, our bones, and the nervous system. Estrogen has even been linked to memory and emotion. As estrogen is depleted, skin begins to lose its tone. Reduced glycosaminoglycans means less moisture in the tissues. Keratinocytes reduce, which means slower cell mitosis. Melanocytes reduce, which means less protective pigment. And cellular exchanges are also reduced. Testosterone levels become dominant as estrogen decreases, which can increase sebum production, which can increase the size of your pores, which can also increase hair growth on the face, which helps to explain why mature women may experience adult onset of acne or facial hair growth. Microcirculation is the circulation of blood from the heart to the arteries, to the capillaries, the venules, and then back to the heart. Hormonal changes are one of the microcirculation problems common in mature skin. One such problem is Cooper's skin, or we also refer to it as telangiectasia, which is the dilation of capillary walls. The endothelium wall of the capillary atrophies and loses its elasticity, and the wall dilates, it fills with blood and sometimes bursting, which causes things like rosacea and other skin inflammations. We also list these as vasodilation disorders, and sometimes they're caused by heredity, your digestive system, use of alcohol, smoking, sun damage, using harsh cosmetics, trauma, pregnancy, excess localized heat, topical corticosteroids, hot and cold or heat and cold fluctuation, and all of these can potentially lead to permanent distension of capillaries, again, hence can lead to things like rosacea. Rosacea is a chronic vascular disorder characterized by varying degrees of skin redness and congestion on the skin. Acneic rosacea includes papules and pustules. We will break more related to rosacea and Cooper's skin down in Chapter 4, Disorders and Diseases of the Skin. Our last and final topic of Chapter 3 is hormone replacement therapy. So hormone replacement therapy is often suggested to balance estrogen for women experiencing menopause. However, some hormone replacement therapy may be linked to breast cancer. Estrogens from plants and estrogens when used in hormone replacement therapy are sometimes derived from plant or animal sources, and estrogens that are derived from plant sources are called phytoestrogens, and they are about 200 to 400 times weaker than animal estrogens. Plants that provide phytoestrogens include Mexican wild yam, soybeans, red clover, sage, hops, black cohosh, flax, St. John's wort, licorice root, and butcher's broom. So just be mindful that choosing a hormone replacement therapy program should be done with the help of a medical professional. It is not within the scope or practice of an esthetician to make recommendations related to hormone replacement therapy. In addition to hormone replacement or hormone balancing, sustaining good nutrition, the use of good skincare products and treatments, exercise, and a positive outlook can keep the skin looking radiant at any age. That is our Chapter 3 review. So we have reviewed the skin as the largest organ of the body. We know that the skin protects us from the environment, which also regulates our body temperature and provides sensation. The skin can be affected quite easily by most salon and spa services. You also want to know what products can penetrate the skin and what effects they will have on your clients. The subcutaneous layer is the deepest layer and contains adipose and loose connective tissue. The dermis is a layer above the epidermis and consists of two layers, which are the papillary and reticular layer. The five layers of the epidermis are stratum germinativum, which is our basal layer, our stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Part of providing skincare services involve understanding how the aging process, sun exposure, hormones, and other influencing factors affects the skin's health and appearance. These are our objectives, 1 through 9, and I hope that this has been helpful and beneficial. We'll see you in our next chapter, which will be chapter 4, Skin Diseases and Disorders. You guys take care and have a great evening.